when we look at this list, one of the things that I just wanted to point out is I'm probably on the quiz. I said that we were going to have multiple choice. There are 27 multiple choice questions, and 2 of them are freebies. Like, if you get a 27 out of 25, you're going to have like 2 free extra credit points. So in the grade book, it's going to go in as 25 points. Students have been able to rely on those extra points from time to time, and it's kind of nice because you can still get 100% and still get a couple wrong. I'm also going to put a question on there that I'm going to ask you to sketch a nonpolar covalent bond, a polar covalent bond, and an ionic bond, and then label the partial and full charges. So within that chemical bonding PowerPoint, there are pictures that show that they show the nonpolar bond kind of like this, with the electrons being shared equally, and then the polar covalent bond shows them being shared unequally, and then the ionic, so with the polar you have a slightly positive end and a slightly negative end, and then with the ionic you typically have no sharing in between. So that's going to be one of the things that I put on there, is to ask you to sketch those things. And then I want to talk a little bit more about water, because I feel like I didn't talk about that enough. So I just want to sketch the water molecule itself. And with the water molecule, we have oxygen here, and we have 2 hydrogens, and the oxygen has a much higher electronegativity value compared to each of the hydrogens, which results in this right here being a polar bond. And the electrons tend to hang out more toward this end compared to this end. So as a molecule, that results in this end having a slightly negative charge. So this little symbol means partial. It's kind of like a figure 8, but it's not quite finished. So this end has a slightly negative charge, and this end has a slightly positive charge, which results in this being, so this is a polar covalent bond with this uneven distribution of charge. Now, one thing that can happen, I find my water molecules. Let's see, it has some alcohol molecules over there. One thing that can happen with water molecules is they can be attracted to each other, and there's this attraction that occurs, and I don't remember if I talked about this much or not, but it's kind of a big deal in chemistry, called the hydrogen bond. And a hydrogen bond occurs where hydrogen bonds to either fluorine, oxygen, or nitrogen. And results in polar covalent bonds. So this molecule here, this isn't the best definition. So it occurs, this occurs where you have to have hydrogen being bonded to either oxygen, fluorine, or nitrogen, FON, F-O-N. And what happens is, because you have slightly charged molecules, between molecules there is an attraction. So if you have another water molecule right here, with oxygen and hydrogen, and it's slightly negative end here, slightly positive, you have these attractions between these forces. So this right here, this attractive force is the hydrogen bond, and it's often abbreviated as H bond. So hydrogen bonding occurs between water molecules. It can occur between, I'll show you an example of one of the units that we're going to learn about soon is the alcohols. So this is a carbon chain, and we have carbon is always black, and then the red is oxygen. So we have this hydrogen right here bonded to the oxygen, which makes this part of the molecule slightly negative and this part slightly positive. So what can happen is, between these molecules, the slightly positive end can have an attractive force with this slightly negative end. In between these two molecules, there's hydrogen bonding that takes place too. So with water, you have like multiple locations for these attractions to take place, because you know this negative end can attract to this hydrogen, it can attract to this hydrogen. So what I would like you to be able to do is sketch several water molecules showing the partial charges. So showing that the hydrogen end has a slightly negative charge. I'm sorry, let me say that again. The hydrogen end has a slightly positive charge, and the oxygen end has a slightly negative charge. And then just showing that attractive force, that hydrogen bonding that's occurring in between. One of the things that we're going to learn about the role of that hydrogen bond is, because of these attractive forces, it makes this group of compounds, which is called an alcohol, much less ready to evaporate compared to the alkanes that we talked about last week, because alkanes don't have any oxygens at all. It has carbons and hydrogens, but alkanes do not have any hydrogen bonding, so they evaporate very easily. But a 2-carbon alcohol molecule is actually a liquid at room temperature. Because of this hydrogen bonding that occurs. The only way it can evaporate is if you can actually have it go into the air, right? Since we have these attractive forces, this hydrogen bonding occurring between these molecules, it creates this force that it resists that. So you have to add enough energy to resist that force to allow it to go into the vapor stage. So I'm not sure what just happened. I think I maybe went into sleep. Yep. With the acids and the bases. Yep.
So when we're sketching that, how do you want us to indicate it? Like your bond?
A common. So I'm glad that you asked that. A common way that we see that hydrogen bond is actually with just kind of a little dot, 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 dot. And we're gonna learn about protein structures that very long protein structures have this like helical sort of structure, and we're going to learn that this is held together, and we'll see like little dot, 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 dot. So it'll be like hydrogen bonding that occurs between molecules. So that little dot, dot, dot is a pretty common way to see the hydrogen bonding. So with the acids and the bases and the salts, I realized when I looked at the quiz that I had made for you that one of the things I am going to ask you to do is be able to tell me what the KW is. Now I said earlier we don't really need to worry about that K, but one thing that we have to know is that if we take the hydronium concentration times the hydroxide concentration that in pure water, that equals 1 times 10 to the negative 14. So this is going to occur in any case, whether you have an acid or a base. The hydronium concentration times the hydroxide concentration is always going to equal 1 times 10 to the negative 14. So earlier, the one thing that I told you is that if we have a hydrogen concentration of 1 times 10 to the negative 4, we could say that the pH was, do you remember? 4. Okay. Now, if I asked you what what the hydroxide ion concentration is, you can also calculate what's called a POH, and it's always going to be 14 minus 4. It's going to be the difference between the two. So the POH would be 10. Now, what's important here is that if I give you one, the other has to be such that, in this case, the hydroxide ion concentration would be 1 times 10 to the negative 10th. So if the hydronium or the hydrogen ion concentration is 1 times 10 to the negative 4th, then the hydroxide ion concentration is going to be 1 times 10 to the negative 10. Because these times each other must equal 1 times 10 to the negative 14. So essentially, the exponents must add up to 14. So here, the example on this board is, if the hydroxide ion is 1 times 10 to the negative 3, then the hydronium is 1 times 10 to the negative 11. So let's just do another example. Let's say that hydrogen ion, or hydronium, because these two are used simultaneously, is 1 times 10 to the negative 8, then the hydroxide concentration would be 1 times 10 to the negative 6. Okay. So I know that there's one question on the quiz where it asks you to do a question like that. Identifying a conjugate acid base pair, listing a formula for hydronium, which is that H3O with a plus. Knowing that an acid plus a base, does anyone remember what an acid plus a base gives us? We get water as 1 plus a salt. So an acid plus a base gives us water plus a salt. And then knowing that pH scale, the 1 through 14, 7 being neutral, 14 being a strong base. And then the last thing is this chemical equilibrium. The thing that I haven't showed you yet is that goofy chicken equilibrium thing. So describing the function of a catalyst, you have a definition in the PowerPoint. predicting whether we're going to shift to the left, shift to the right, distinguishing between endothermic and exothermic reactions, demonstrate how to identify a buffer solution. We're going to review that right now very quickly. And then the purpose of a buffer solution. And then I have one more, explain the blood buffer system, alkalosis and acidosis, which is this chicken activity. So let's just look at the chicken activity. This is one that I don't know if there's sound at the target, cannot be open in a new tab, security. So it says equilibrium plays a vital role in everyday life. Click on the forward arrow to proceed. I wish I had a smart board. That would be really handy. All right, so the question is, do chickens sweat? Do you guys know if chickens sweat? I don't either, but I don't think they do. We're gonna say no. All right, correct. Chickens do not sweat. They pant like dogs to evaporate water and dissipate heat. All right, so on a hot summer day, the chicken is panting or hyperventilating. All right, so if he's hyperventilating, what do they tell us to do when we hyperventilate? Do you guys know? Breathe slower. Have you heard the breathe into a paper bag? Yeah, breathe into a paper bag. It's because we're losing so much carbon dioxide. And when we lose a lot of carbon dioxide, our blood balance gets kind of goofed up, and we need to get the carbon dioxide back in the body. So we have this equation here. If our body is losing carbon dioxide, what can happen is, so the carbon dioxide is being pulled out, what can happen is we can get a shift in this equilibrium, and we have like two equilibriums here, but it really behaves the same way. So we can get a shift in this general direction to have the body replace some of that carbon dioxide. Let me just finish here with the activity. So it's time to apply the concepts of equilibrium. I want to set this up so that it's kind of looking at the board. So a stresses to a reaction in equilibrium is an increase or decrease in one of the substances. So systems will respond to the stress by shifting away from an increase. So remember, if we are increasing on one side, we're pushing away, we're shifting away. And a decrease results in the opposite. So if we're removing from a side, we're going to be kind of pulling in the opposite direction. So on a hot summer day, when the chicken is panting or hyperventilating, what do you have? What? Oh.
Thank you.
I thought maybe you left something in here.
I lost myself and all this stuff.
Yeah.
Sorry.
It's okay. I'm so used to him coming in here, I just thought it was for me, but I shouldn't flatter myself. So on a hot summer day, the chicken is panting, and the hyperventilation is explained in the following equation. So it's reducing, it's like giving off a lot of carbon dioxide. So if the stress is that we're losing carbon dioxide, which of these arrows would we choose? That carbon dioxide is increasing, carbon dioxide is decreasing? Yep, all right. So congratulations, you are correct. The chicken is losing carbon dioxide via breathing. All right. So when when this happens, what is the response of the equation in the equilibrium to the decreased carbon dioxide? So are we going to shift towards the carbon dioxide, or are we going to shift away from the carbon dioxide? Towards. All right. Ding, ding, ding. Congratulations, you are right. The system responds to stress by shifting toward a decrease, meaning that the production of chemicals on the same side of the decrease is favored. So next, this is just kind of showing that stress. So the stress is to reduce carbon dioxide. The response is to shift in this direction, which will produce an increase in that. It's going to, if we're shifting this way, we're going to be getting a decrease in hydrogen ion concentration. Now, as a result, if we're decreasing this hydrogen ion concentration, we are removing hydrogen ions from this, which is, the hydrogen ions is what will give the acid properties. So if we're removing, if this is decreasing, then the result is going to be the environment is going to become more basic. So when the hydrogen ion concentration decreases, hydroxide ion increases, and pH will go up. So we're going to end up having a condition that is more basic. Now this could cause a condition called alkalosis. So alkalosis is a condition in which you're losing carbon dioxide, you're losing too much carbon dioxide, and as a result, this equilibrium shifts in this direction, lowers the hydrogen ion concentration. Excuse me. So as that hydrogen ion concentration decreases, naturally the hydroxide ion is going to increase, which is going to make that environment more basic. Now, another synonym used for base is alkaline. An alkaline condition is considered a basic condition, which is the opposite of the acidic condition. Alkalosis in the human body can lead to a lot of different conditions, but I don't know what they are off the top of my head, and I apologize. Last year when I gave this lecture, I looked it up, and I forgot to this time. But you may hear those words as nurses. I'm sure you will hear those words as nurses. So to avoid death from alkalosis, the chicken should breathe into a paper bag. Now that's not indicating that if any of you start to hyperventilate, you're going to die, but a chicken might. You know, a chicken's a little thing. All right, so here we have a chicken smoking a cigarette, which is very applicable to us. I don't know if any of you are smokers or have been, or I'm thankfully not, but many people in my family are addicted to it, and it's really hard to not be addicted. So smoking cigarettes increases emphysema, and that decreases the lungs' ability to exchange gases. So what can happen is if your body is not able to remove the carbon dioxide properly, it's going to result in an increase in carbon dioxide in your body. So your lungs aren't able to function properly. You're not able to exhale out that carbon dioxide. You get a buildup of carbon dioxide in the body. So we're going to increase this. If we shift in this direction, we're going to be increasing the hydrogen ion concentration and result in a condition called acidosis. So I know it says think carefully, but I just went through all of the answers. So increasing CO2 in our body, the chicken is impaired in the ability to eliminate that CO2 via the lungs. The response then is to shift away from the CO2 towards the hydrogen ions. So stress increasing the CO2, we shift in that direction. It results in the hydrogen ion concentration increasing, which causes acidosis, which could also be fatal to the chicken. So to save the chicken from dying of acidosis, one of the things that can be given to the chicken or anybody else that has acidosis because of carbon dioxide not being removed from the body properly is to administer sodium bicarbonate. It's something that will neutralize, it'll neutralize those hydrogen ions and take them out of this, which will, it would appear that it would cause this kind of shift, but now I'm really confused. Oh, no, the bicarbonate ion is this. I feel foolish. So sodium bicarbonate, this is bicarbonate. If we add sodium bicarbonate, which is baking soda, now I don't encourage any of you to try and make a baking soda solution and try to inject it in your veins if you think that you have acidosis. I am not a physician, but they probably have very, very fine medical grade quality into an IV, and it will push the reaction back that way, reducing those, the acid from building up. All right, so that is the conclusion of the chicken activity. So essentially what I wanted you to take from that, it says explain the blood buffer system. So I might have that diagram up there and say explain what happens when a person is losing carbon dioxide because of hyperventilation and what results. Now, you don't need to give me a diagnostic of what alkalosis is, other than to know that it is a more basic condition, and then acidosis is acidic, and it's a result specifically of either having too much carbon dioxide in the body, a buildup of carbon dioxide because your body can't eliminate it properly, resulting in this acidic environment, or your body getting rid of too much carbon dioxide. So, what's that? I cannot remember. Maybe you guys can help me. I know that we built the models last time. I think we were about to start talking about yeah, like the alkanes, like properties. There was gasoline, and I think I briefly talked about reactions